imperative that you understand everything, but it is useful to know what is being calculated because it helps your analysis later. So we'll just calculate the raster. So we just want to input the raster. I'm going to be using the Capri Arc 25 meter. And then we need to click on that browse box to just say where we're going to save the results. So I'm going to save it in a specific place. Now what I'm going to do is when I get to my Capri Arc folder, I'm going to add another folder and then call it slope. I'm going to put all my slope raster data in here. So we're going to calculate a few, so double click on it. First one we're going to do is the slope with the Z factor of 1. So we're going to call it 25 meter and then 1. So I'll just let you know, if we were then to have a character name that's over 13 characters long, sorry, a file name that's over 13 characters long, you'll get this little red circle with a white cross. If you click on it, it will tell you that the name is longer than 13, and that means 13 characters. So we need to change that. So we just go back to the browse, you'll empty the name, just call it slope 25 meter 1, and then save, and you'll see that the red box is gone. We're going to keep it as degrees, so we're calculating the degrees, and we'll keep the Z factor as 1. Now the Z factor is a way you can change the height compared to the XY. So the XYs are two-dimensional, north and eastings, and Z is height. So you can change that in order to sort of see subtle differences in the height. So this will be quite evident when we calculate the 1. So having 1 means that it keeps the Z factor exactly the same as the XY factor. So 1 meter north and south is the same as 1 meter height, which is correct, but sometimes it doesn't help in visualization. So we'll just click OK. It will calculate it. It will say something about the datum being incorrect. That just means that it's again the coordinate system being different. We don't need to worry about it too much. It will sort of put it in the right place anyway. So here you'll see that it's calculated the slope, but the only one it's really showing is this very high slope value. So this is correct in terms of, the values for slope are correct. So when it comes to the analysis, that slope needs to be actually sort of resulted as 89 degrees, but it's not very helpful in terms of sort of working out where there is slope. So we'll recalculate slope. If we just go back to the slope tool, we'll input the same raster, and we'll just output it. This time we'll call it slope 25 meter 001. So what we're going to do is change the Z factor to be less. So this will mean that it's going to pick up the differences in slope that are more subtle. So we just press OK. Basically, this is also trial and error, so have a play around with it. You can try 0.1, 0.0001, just see what works, because I guess the one thing to note is that when you're actually, as I say, giving a result, you can't actually state that that this is 89 if it's not. The only one that's actually true is this, the 1 meter, in terms of actually the results. But if you don't have to give specific details on the actual slope, you just want to show where there is slope changes, then you can use this 001. So I'll just turn this one below it off, because you'll see here it's much better at picking out these differences. So this is actually where slope is occurring, but it's difficult to say that these are completely right because you've manipulated the Z value. Now if we want to change this to be a bit more smooth, because at the moment it's in these sort of groupings. We'll double click. It'll now say that the unique histogram doesn't exist. We can just press no, because we don't want a histogram, we want these stretched. So that means you can't do the classified, which is what it's already done. It won't sort of work out a value for each individual raster, each cell. So what a good one to do